Hello and welcome to Cannon County High School Algebra 2. Yesterday we talked a little bit about the sine, cosine, and tangent ratios on right triangles. We talked about how sine is opposite over hypotenuse and cosine is the adjacent over hypotenuse and tangent is opposite over adjacent. Today we're going to look at the sine, cosine, and tangent of some of those special angles that we talked about the other day. For instance, 30, 60, 90 triangles and 45, 45, 90 triangles. And while doing that, we're going to see how they relate to the unit circle, and that's going to help us to graph them eventually and actually talk about sine and cosine functions, which is what we're eventually getting to. So Mr. Lyon, you're going to have to sit over here. Excuse me. We're going to talk about the unit circle today. That is not a unit circle. That's a quarter of the unit circle. I want you to be able to see this, and so I've only drawn half, or a quarter rather, of the unit circle. And you know that a unit circle has a radius of 1. So the distance from here to here is 1. And the unit circle, again, has a radius of 1. Imagine it going all the way around. The center of the circle is at the origin. So you've got an x-axis here, you've got a y-axis here. What I'd like to do is draw an angle, theta, that is 30 degrees. And 30 degrees, you know, is the same as what in radians? 30 degrees is how many radians? Do you know? Sure you do. We did this the other day. 30 degrees times pi divided by 180. 30 divided by 180 is 1/6. So that means the answer is pi over 6. So 30 degrees is the same as pi over 6. So two ways of measuring the same angle, 30 degrees, pi over 6. This point right here, the distance from here to here would be 1 because this is a unit circle. If I were to drop down an altitude right here, a right angle, just like that, if this angle was 90 and this angle was 30, then what would this angle have to be? That's right, it's 60. And therefore, we can use 30, 60, 90 triangle just like we did the other day. So if you look at the 30, 60, 90 triangle, the reference card that I have here, the hypotenuse here is 1. If I wanted to find what the short side was, well, to go from hypotenuse to short side, you divide by 2. 1 divided by 2 is a half. And so that means that the y-coordinate of this point is going to be 1/2 because the distance from here to here has to be 1/2. And if I wanted to find the distance from here to here, I would have to take, well, the short side, the short leg times the square root of 3 is equal to that longer leg. And so 1/2 times the square root of 3 is the square root of 3 divided by 2. So what we've been able to do is find the coordinates of the ordered pair that's on the unit circle for a 30 degree or pi over 6 radians angle. Now, if this side is 1/2 and this side is the square root of 3 divided by 2. I know that's small, but I'm gonna be drawing some other things on here, so you'll see why in a minute. What is the sine of 30 degrees? Well, the sine would be the opposite side divided by the hypotenuse. 1/2 divided by 1 is 1/2. The sine is 1/2. What's the cosine? The cosine would be the adjacent side divided by the hypotenuse. So the cosine is the square root of 3 over 2 divided by 1, which is the square root of 3 over 2. Why do we care? Because if we use a unit circle to do this, that means that the x-coordinate is going to be the cosine and the y-coordinate is going to be the sine. So I'm going to write that down up here. Anytime you have an ordered pair on the unit circle, the cosine is going to be the x-coordinate, the sine is going to be the y-coordinate. Okay, that is important because that will make a lot of things easier as we go. Okay, let's try a different angle. 45 degrees. Okay, let's say this is a 45-degree angle. And I don't want to get this too messy, so down here, let's figure out 45 degrees. What is that in radians? Well, let's see, that's going to be times pi over 180. And 45 divided by 180 is 1/4, so that would be pi over 4. So 45 degrees is the same as pi over 4 radians. Well, let's do the same thing. I know this is getting a little bit busy here, but you get the idea. The distance from here to here is still 1. It's still a unit circle. Now, I'm going to draw this down here so you can see it a little better. What I've made is a 45-45, this is just like yesterday, a 45-45, 90 triangle where the hypotenuse is 1. So how do you find one of the legs? Well, let's look at our reference from the other day. To go from the hypotenuse to the leg, you would divide by the square root of 2. So what is 1 divided by the square root of 2? Well, if I want to put that in simplest radical form, I'd have to multiply by a form of 1 that gets rid of that square root of 2, which would be the square root of 2 divided by the square root of 2. That would be the square root of 2 over the square root of 4, which is 2. So that means that both this side and this side is the square root of 2 divided by 2. Which means, and this is the important part, back here on our unit circle, what is the x-coordinate of this point? It would be the square root of 2 divided by 2. And what would be the y-coordinate? It would be the square root of 2 divided by 2. Why is that important? Because now I know that the cosine and the sine of a 45-degree angle is the square root of 2 divided by 2. That's it. All right, there's one more special triangle that we need to talk about, and that is a 60 degree. So let's talk about this one, a 60 degree, all the way up to there. Well, let's drop that down, and I know this is getting kind of busy, but I'm going to write it, I'm going to make it easier for us down here. Here we go. It looks kind of like this, where we know that this radius of the circle is still 1. Okay? Now let's use our reference triangles from the other day. If we know that the hypotenuse is 1, how do you go from the hypotenuse to the short side? You divide by 2. So that's a half. Again, there's the right angle, there's the 60-degree angle, and there's the 30-degree angle. How do you go from the short side to the long side? You multiply by the square root of 3. So that's the square root of 3 divided by 2. Therefore, on our unit circle up here, that means that the x-coordinate is 1/2. The y-coordinate is the square root of 3 divided by 2. Notice, what do you notice about the cosine and sine of a 30-degree angle and a 60-degree angle? Yeah, the cosine and the sine swap. For the cosine of a 30-degree angle, you get the square root of 3 over 2. The sine of a 60-degree angle is square root of 3 over 2. The sine of a 30-degree angle is 1/2. The cosine of a 60-degree angle is 1/2. They just swap. Okay? Now, this is important because this will allow us to graph anything on the unit circle now that you know these special angles. So for instance, what about 0 degrees? Now that you understand how that works on a unit circle, what is the coordinate of this point right here? Well, I know this is a unit circle, so I know that that distance right there is 1. So this is the point 1, 0. So if I were to ask you, what is the cosine of 0 degrees? Or you would say 1. What is the sine of 0 degrees? It's 0. How about 90 degrees? Way up here. What's the cosine? Well, you know this is a unit circle, so you know the coordinates of this point are going to be 0, 1. And since the cosine is the x-coordinate, the cosine of 90 degrees is 0, the sine is 1. By the way, what is 90 degrees in radians? Remember, 90 times pi over 180. 90 divided by 180 is 1/2, so that would be pi over 2. So 90 degrees and pi over 2, same thing, just measured two different ways. So this is a quarter of the unit circle. What if we applied that to the entire unit circle? Aha! I know you probably don't have your textbook at home, but this is page M447 of your textbook. And if I zoom in, you can see this uses the entire circle. But you can see that we've got this kind of set up already. Notice this says 30 degrees, which is pi over 6 radians. They're the same thing. And the cosine is the square root of 3 over 2. The sine is 1/2. 45 degrees, pi over 4 radians. Cosine is square root of 2 over 2. Sine is square root of 2 over 2, just like we did before. 60 degrees, pi over 3 radians, same thing. 1/2 square root of 3 over 2. And because it's a unit circle, 0 radians, which is 0 degrees, 1 is the cosine, 0 is the sine. And for 90 degrees, which is pi over 2 radians, we have 0 and 1. 0 is the cosine, 1 is the sine. Okay? So, what does that mean? Well, that means that we can now figure out what the cosine and sine is of any angle that is a multiple of these special angles. So let me zoom in on just the top half of the circle so you can see this. What if you were asked to go over here to 2 pi over 3 radians, which is the same as 120 degrees? If I asked you the sine or cosine of 120 degrees, you could just now use the unit circle and the sine and cosine of these reference angles to figure it out very easily. Because in quadrant 2, the cosine is negative and the sine is positive. Because you know that all the ordered pairs in quadrant 2 go negative for the x-coordinate and plus for the y-coordinate. Just like in quadrant 1, they're positive for the x-coordinate and positive for the y-coordinate. So what are the coordinates of this point? Well, forget about all this stuff in the middle. If I just ask you what are the coordinates of this point, you would say to me, well, it sure looks like the y value is for this one is the same as the y value for that one. And you're right, it's the square root of 3 over 2. But what do you think the x-coordinate is? If this is positive 1/2, then this is, negative 1/2. So that means the coordinate here is negative 1/2 positive square root of 3 over 2. And notice as we go around the circle, all we do is change the signs of these reference angles over here to match quadrant 2, negative, positive. So for this one, you're going to have negative square root of 2 over 2, positive square root of 2 over 2. On this one, it's going to be negative square root of 3 over 2, positive 1/2. Okay? See how that works? Now let's go down to quadrant 3. Well, let's see if I can zoom out rather, a little bit so you can see this. Let's use the angles from quadrant 2 to help us with quadrant 3. Well, in quadrant 3, you know that the sine and cosine are both negative because you have a negative x-coordinate and a negative y-coordinate. So you put the same exact sines and cosines, it's just that they're both negative. So for this one, you would say that's negative square root of 3 over 2, negative 1/2 for 7 pi over 6, which is 210 degrees. For 5 pi over 4, which is 225 degrees, that's going to be negative square root of 2 over 2, negative square root of 2 over 2. And for 4 pi over 3, which is 240, that would be negative 1/2 and negative square root of 3 over 2. Almost done. Let's go over to quadrant 4. Quadrant 4. Now in quadrant 4, the cosine is positive and the sine is negative because that means the x-coordinate is positive and the y-coordinate is negative. So let's keep going. That means that for this one, you're going to get positive 1/2, negative square root of 3 over 2. For 7 pi over 4, we get positive square root of 2 over 2, negative square root of 2 over 2. And for 11 pi over 6, you get positive square root of 3 over 2, negative 1/2. Whew, that's a lot. That is a lot. But that is gonna make things so much easier for us. Now, do you have to memorize all this? No, you don't have to memorize all this. You do kind of have to figure out, you've only got 3 numbers to remember. You've got a half, square root of 3 over 2, and the square root of 2 over 2. The only other thing you have to remember is which quadrant you're in. Because if you're in quadrant 2, you know it's gonna be a negative cosine and a positive sine. If you're down here in quadrant 3, you know you're going to have a negative cosine and a negative sine. If you're down here in quadrant 4, you know you're going to have a positive cosine and a negative sine. Okay? So, I think that's enough for today. I'm not going to have you do an IXL for this until next week because I want to explain it just a little bit more. This is Thursday and tomorrow is Good Friday, and so I won't be putting up any videos on Good Friday because we don't have school technically on Good Friday. So I hope all of you have a wonderful Easter weekend, and I will talk to you again on Monday where we will talk a little bit more about this and how we're going to use these to quickly and easily figure out sine, cosine, and tangent of these special angles. Have a wonderful Easter. Bye.